Greetings, welcome back to our more regularly scheduled series of meetings. The first thing I wanted to let you know is that the slide deck I'm showing to you now is hosted directly on my website in the reveal.js framework. You can find a link to it right now on the portfolio page of my website in the section on presentations. It's currently all the way down at the bottom. It is a live interactive web app, and the link is shown below at the bottom of this page. First thing I want to give you a heads up on is what we're going to cover. A lot of different kinds of people will be involved in any kind of engagement or process, but they're all trying to work together to do the same thing. Working is always done iteratively until everyone reaches agreement. And this can happen differently depending on where you are in the project. Phases do not always flow in the same order. So this is not a cookie cutter do A, B, C, D kind of framework or guideline for how you work together to get things done. It's more of an art than a science. That said, there are a lot of standard steps. They do happen roughly in the same order, but you can iterate within phases, and you can also iterate back and forth between phases. So everything happens, even if not everyone is involved in every step, and even if it doesn't look like it. Different kinds of work are done at different specific times in the project, recognizing where you are and how this may look different in the specific work you're doing helps you understand what work to actually do and helps everyone develop a shared awareness. So here's an important piece of context you should know. Most business analysis work involves the development and modification of software systems. We sometimes go through the study questions and do practice exams using questions provided by Watermark. They explicitly say, as I understand it, that all of their test questions should be understood to be in a software context. We just finished a SDLC simulation, so obviously, because software is in the name, it's obviously about software. However, I tend to think of all this stuff in a more general way. So you can apply this framework to any kind of work you're doing. Here's another thing to understand. It's really, really good to understand everything that's going to be involved in what you're doing before you start, so you know what to expect. All the different people involved will be thinking about different things and doing work, but they all have to be able to work together in a shared context. There are going to be enough surprises in the work. Don't let the fact that you don't know what is coming procedurally add to the confusion. The more you know up front, the better off you'll be. Working together means having conversations. You basically never complete anything you do on the first try. It always involves iteration. So a conversation, if you're talking with one other person, there's a certain amount of back and forth that is involved before you can reach a shared mutual understanding. The way I represent this is basically a circular loop where you just go around and around. And I show this with entries and exits going both forwards and backwards. So if you have a number of phases, you can move forward from left to right or go back from right to left. Why do I show things like this? So normally you're working your way through the phases, moving forward as work proceeds. That's the general trend. But there are a lot of times when you learn new things, you change your mind, you get extra information, you have new insights, you realize you need to go back and change something, add something, delete something you did in a previous step. So this framework allows you to have a lot of consecutive conversations and shared work going in both directions. And this is just a shorthand way to graphically show that. Another thing you need to understand is that there are four different components of any work you do. One is the process. So this is the series of steps your business, organization, or whatever goes through to get something done. There are standard type of general components involved in it. I'm not going to talk about this in detail. I have spoken and written about it extensively. What we're here to do today is talk about the engagement, which is the structured process of doing the actual work. So the process is the working system you either create or modify and that's the picture on the left. The solution is the change you make to the system to either create or change it. The engagement is the work you do to create the solution. And the rest of the talk will be about the structure of those engagements. Because no matter how you think about it, they all work more or less the same way. And all those elements are in the environment, the working environment, the corporate environment, the organizational environment. Also, there are links to further discussions, either blog posts, videos, slide decks, other links elsewhere on the internet buried throughout these pages. So feel free, if you're curious about any of this stuff, to go and see more. So where do we start? I used to do swing dancing when I was healthy enough to do so. And my favorite dance is based on a very simple step, a basic set of moves I could teach you in 5 minutes. Now, after 5 minutes, you will not be good at it, but any place you go where they're playing the appropriate kind of music, you can do what I show you. You can dance all night long. You can have a great time, and everybody will understand what dance you're trying to do. So back in the day when this dance was created in the region around LA and Orange County and ballrooms all up and down the coast and elsewhere, people could tell what high school you went to by the way you did your facing. So people tend to do things in their different ways, driven by their experience and preferences, and also by history and influences in that time and place. There are a zillion different ways of doing things. You can spend forever doing things differently or better, but we have to pick one and start somewhere. So I'm going to show you one basic way to approach these, and you can spend the rest of your career and life figuring out, going deeper, learning more, adding variations, adding your own insights. Everybody that is on this call now already has a decent picture of all these things, so I'm just adding context to it. And that's particularly true for the people who just did the SDLC simulation with us over the previous 11 weeks. So who am I? I only half-kiddingly call myself the world's greatest process analyst. And I got that way by being a process engineer and analyst specializing in computer simulation. I did the two main kinds of computer simulation. Most people tend to specialize in one or the other. I worked in a lot of different industries, doing applications that accomplished a lot of different things. there are a lot of architectural considerations you have to be aware of in simulation, so I worked on a bunch of them. On the left is an example of a continuous simulation, and on the right is an example of a discrete event Monte Carlo simulation. So we needed to start somewhere, so here is our somewhere. For this discussion, we're going to talk about or think about doing projects as if we're building a simulation of a system that already exists. And that's the simulation is of a process consisting of multiple steps like that shown in the diagram on the right, on the left on the previous page, or on the right. So who is going to be involved? I mean, sometimes projects are done standalone, but work on any scale involves multiple people. And if you have multiple people, that means they all have to talk, they have to have empathy and respect, they have to have a shared terminology and language, they have to have patience, they have to work together to achieve agreement. And this all happens in a managed environment of limited resources. So you need to remember that 70% of large transformation projects still fail. After all these years, we've been talking about business analysis, project management, system design, and all these other methodologies. 70% of the time when we're doing anything at scale, we still fail. Well, that's kind of ridiculous. Why do we fail? We fail because we don't talk to each other enough and we don't do enough analysis. So everything I'm talking about here has to do with being sufficiently thorough and communicative to give ourselves the best possible shot at success. So we start off by figuring what we want the simulation to do. There are a lot of reasons to use simulations. I showed some of them on a previous page. We don't build them unless they provide some kind of value. Simulation has to be accurate enough to be meaningful. There's a famous saying in simulation that all simulations are wrong, some are useful. And as we go through the process of building and using simulations, we may learn more about them so that we can change them, use them for different or more things, and so on. If we're going to simulate something, we need to understand the thing we're going to simulate. So we do that by doing discovery and data collection. Discovery involves finding out what the existing system done, what parts it consists of, and what happens inside that. Those are your nouns and verbs, the components and actions. Different industries might have fairly standard components. There are fairly philosophically standard components that are involved. And the more you deal with these things, the more you'll see that and see the commonalities. There are a lot of ways to do discovery, use all of them that work. Similarly, with data collection, once we know what's going on in a system, we can characterize it by putting numbers and enumerations and types on it. Those are your adjectives and adverbs. So there are a lot of different kinds of data. They have different ranges of values, different formats, they mean different things. You have to find out what they all mean and document everything. Again, there are a lot of ways to do that. Use them all. Use whatever is best for your situation. The other thing about data is it might be messy. So you have to figure out how to use it effectively or otherwise address what you might be missing, what might be noisy, and so on. Now we have to identify what our customer needs. Everybody has needs, all the different players, and the solution may have needs of its own. The earlier we find those out accurately, the better, although we may find out down the road and have to come back and add to what we know. There's a critical difference when we're thinking about what people need, and that is the difference between what a solution does and what a solution is. So what it does is pretty straightforward, and we covered a lot of that implicitly during the SDLC exercise we just finished. We did not get into talking about what the solution is or other qualities it needs to have. But think of it this way: if there are two solutions and one is simpler, faster, easier to maintain, and easier to modify, well, that'll be the better solution, all other things being equal. So when we establish requirements, we have to have a way of judging whether those requirements have been met or whether those needs have been met. And we need to agree on that ahead of time. So there are a lot of ways to solve problems. We need to think about what they are and identify the best one. So in terms of simulation, we have to consider everything the system does, and then we might be able to, based on what kind of analysis we're doing, figure out whether some things can be omitted or simplified. There are a lot of good reasons for simplifying things, but they should be understood and agreed to and documented. We also have to think about the risks and impacts and document that. And thinking about risks and impacts is something we'll do all the way through the work. on any project. There are many ways to evaluate and rank solutions, and they may differ based on your situation. A classic way to do it is by comparing which one has the greatest cost benefit ratio based on monetary calculations, but that's not the only way. There are a lot of things organizations may be trying to accomplish, and they aren't all driven by the same incentives. So you need to consider everything your solution does over its entire life cycle to decide which one is best. That would be ideal. People don't always do this, but the more you're aware that that is the ideal, the better chance you'll have of being thorough and thinking about everything you need to. Once you've figured out what you need and how you're going to address those needs, then you go ahead and realize the needs. So solutions should be as simple as possible, but no simpler. Make things streamlined as much as possible, but make sure it does everything you need to. Don't add extra features out of a sense of completeness or because they're cool. You might implement solutions in steps instead of all at once. When you hand over a solution, the training, documentation, and management and maintenance procedures are all part of it. I tend to want to do things in as standard and modular a way as possible. I've learned over many projects that greatly simplifies things, and there are some abstract ways you could do that, but it takes time to learn. If you're doing a single project and then going back and modifying it or selling similar solutions to different customers over time, every time you iterate and create something new, you've got a chance to make the process and make your solutions better in this way. Initial solutions tend to be custom, expensive, and brittle, and they tend to become more standard, less expensive, and more robust over time. Think about cars. Well, they're getting more expensive, but you get the general idea. If you want things that are getting cheaper, think about computers. Once we build the thing and then we test it, and every aspect of a solution has to be tested in a lot of different ways. It should be planned for from the beginning. Solutions should be evaluated on how they work and, almost more importantly, how they address the stated problem. What do you mean almost? Absolutely, that's the important thing. So you need both. It does no good to make a system that works perfectly and quickly and whatever, but solves the wrong problem or doesn't solve your problem at all. That happens. Avoid it. Again, we've talked previously about the criteria for things passing and being judged to be acceptable. We want pass-fail answers as much as possible. Automated tests of functionality and so on tend to be more hard yes and no evaluations, but other evaluations are based on expert judgment and how people feel about that. So I will break that down further a little bit later. The market provides the ultimate test, and it's not something you can do. You can do something you think is great. If the market doesn't like it, it doesn't matter. That isn't always fair, but you're always trying to satisfy customers. It might be one customer you're doing a specific thing for. That customer may be internal or external, or it may be a mass customer base. And that latter is what I'm generally talking about. So let's summarize. We'll define the problem, figure out what's going on now, identify what is needed, figure out a design, build out the design, and then test it, then deploy and hand it over. Now, let's think about what our project manager does with this work. We have all the steps, but the project manager has to think about a few extra things. They have to provision and launch the project. They have to get the resources for it, which is money, tools, people, places to do the work, materials, test equipment, and so on. Manufacturing equipment, materials, permissions, a whole bunch of things. Then, once the work is underway, they have to continually adjust their plans and monitor the ongoing work. They have to figure out what to simplify or omit and the effects of doing so. And they have to, once all the work is done, close it down. And ideally, that will mean maintaining and filing away all the records, having a review to capture lessons learned, provide training and feedback so the organization as a whole continues to improve. So let's look at the framework. Again, the vast majority of what we're talking about is the engagement. This is the structure of us doing the work on a process to generate a solution in an environment. So we're only talking about the engagement. So we have the project planning. Because I come out of simulation, I call the initiation or the ideation phase the intended use. Then we do assumptions, capabilities, limitations, and risks and impacts. Um, so that's all part of trying to figure out what this thing is gonna do. and the effects of making various decisions. Now, it's shown here near the beginning, but all those are things that really are performed, particularly in the risks and impacts, all through the process. Then we do the conceptual model. So that's the as-is state. Remember, sometimes we're building a new system from the ground up. There is no as-is state. But for this exercise, we're just starting in a specific place. We assume there's something already there that we're going to modify. And before we start, we have to figure out what's going on. Then we do all the data stuff. It's really part of the conceptual model. Remember that conceptual modeling things about both discovery and data collection. But data is enough of a big deal, both to build the model or the system that we're building the solution, and how to run it. That we included here as a separate idea. Then we have requirements. These are an abstract form of the to-be state. It's your first shot at it. And I will explicitly break this down into functional and non-functional requirements. So I've hinted at this before. Functional requirement, which is just what we did in the recently completed SDLC exercise, or about what a system or solution does. Non-functional, or what the system is. Those are the qualities it has: the approachability, usability, speed, robustness, maintainability, that kind of thing. Then we do the design based on the requirements. That's a detailed form of the to-be state. Then we do the implementation, then we do tests. Now I've hinted in this also. We will talk about two forms of testing. One is verification, which asks the question, does the thing I just built work correctly the way I intended it to? The other half is validation, and that is about determining whether the thing I just built that works correctly actually answers the business or organizational need. Does it answer the question we originally asked? Once you do all the testing, you will do acceptance and handover, and that can be full acceptance, partial acceptance, and you'll have to go back and fix more stuff. Partial acceptance, and yeah, good enough, we're not paying for you to make it better. And then there's not acceptance, scrap the whole thing or go back and try again, or we'll see you in court. So that's what acceptance is all about. And just as we have a project opening and planning phase, we have a project close phase. So now that we've talked about that, let's think about it in a more streamlined way. Let's take out a lot of the fluff and just cut it down to the basics, the things we actually do to come up with a solution and deliver it without thinking about the management and all the stuff we're doing implicitly all throughout the project. So that looks like this, and now we'll show it even one more way. So I'll call this the customer feedback cycle. Remember at the beginning I said all the work we do in all the different phases basically involves having a conversation where we work together, we go back and forth until everybody has reached agreement. So we come in here at the left at the intended use, we go around until we have an agreed upon write-up for that, only a handful of items usually, and then we move forward. Then we get to the conceptual model, which is figuring out what's going on now. So again, we'll iterate around and around, and especially for the conceptual modeling, we'll find out what's going on. We'll ask a whole bunch of questions. We'll collect a lot of information. We'll document the whole thing. Then we'll show it back to the customer who showed us all this stuff and explained it to us. And they will review whether or not we have a correct and complete understanding. And if we don't, we keep correcting and adding things and changing things until we get it. So we do that iteratively through all the phases until we're done. So the reason I show things this way is iteration happens within every phase, between all the participants, and also between phases. It's usually forward, but it can be backwards too as more is learned. Now, the most classic form of iteration between phases is between implementation and test. So I build something, I test it, find out it doesn't work, go back to implementation and I change it or redo it in some way, and then I test it again and I keep doing that until it's proper, until it's correct. So that can really happen everywhere. And I'll show that near the end of this presentation, how you can track all that work. In the meantime, we have a ton of stuff to cover. So even though all the work is iterative, works in a certain order, you can use that format or this way of thinking about the phases in any kind of management protocol you want. So if you're doing waterfall ideally you just march through all the processes in order and then you'll be done. You can do that for a super trivial project, maybe. But in reality, people have been iterating within and between phases since the beginning of time. I often like to say that I've been doing Agile since before Agile had a name. So if you're doing explicitly Agile and Scrum, you will go ahead and do the first three phases: intended use, conceptual model, and requirements to put items in a backlog, and then you'll groom that in priority order. You'll take things off the backlog and do design implementation, test, and delivering. And you may have a hybrid situation where you have the overall design of the thing kind of worked out, and then you're just doing a kind of iterative thing with the actual implementation. If you're building a simulation to help you do your design and implementation, you can manage the construction of the simulation as an independent project with all the same phases embedded into the larger project. So I talked about improving in an existing project. We do discovery and data collection to build a conceptual model of the thing that already exists. But what if there is not a new system? What if or an existing system? What if we are starting from scratch? In that case, we have to figure out requirements, and then we do conceptual modeling, the discovery and data collection and manipulation embedded in the design process. So it's an interesting way of thinking about stuff. That's one of the biggest differences between doing projects. And I should say that even if you're doing something new, you might have a lot of conceptual model information based on previous work you've done that's similar. So you're not going to be doing stuff that's super new all that often. I work for a lot of companies that deliver custom solutions over time, but they were all very similar to each other, even if the details were different. So let's talk about the extended life cycle. So these first six, hopefully you can see the cursor here. These first six phases are the phases we work through iteratively and so on to build the initial system. And then we turn it over to the customer, and then they operate, maintain this thing over time. Well, part of that operating and maintaining it is they're going to do ongoing modifications. So, and upgrades and changes and repairs and other things. And every one of those efforts will be an engagement of its own with all the phases. And we do that work the same way we do any other one, as most of the work we do involves modifying something that's already there. You're going to be working in these little things here most of the time. And then when a system finally ages out, it is no longer tenable for any number of reasons. It gets the end of life and replacement. So there are a lot of things you can do. I've seen factories shipped off to lesser developed countries. I've seen old systems replaced by new systems, manual processes replaced by fully automated ones, or they might stop doing something altogether and do something completely different. So when you get to the end of the initial project, that only hails the start of managing the full life cycle. Um, when you're in the operation and maintenance part of the system's life cycle, you may never have a closing phase. You may have several things going on at once. People may be working in every phase of one or more engagements at the same time, and you'll never really close. Now, I usually worked for vendors or consultants. So the work we did for customers, we came in from outside. Our communications were more formal and more guiding, involved more documentation, and usually had a defined endpoint. For in-house work, when you're having internal teams working on internal systems, you should have all the requisite documentation for your own good, but you may not have super formal closing. All right. Another thing to think about is that work in any different phase or any individual phase may have multiple layers to it. I'll give some examples on the next page. This can happen in almost any phase. I'll show three options here. One is that I may do three stages of design. So I show them serially embedded in the process on the top depiction. Here in the middle depiction, I have three all going on in parallel. So think of we're designing some sort of computer system. We have to think about things at the abstract or business level. What information do we need? What actions do we take? What decisions do we make? What do we actually need for that? And then we figure out how to do the front end and the back end and the networking and so on, and how the problem needs to be broken down and handled in different components. And then we might worry about the hardware and the physical networking operating in the security environment that all happens in. We may do that iteratively between those three things in parallel. And the bottom is just another way to show that, the work in any phase may involve a lot of separate pieces. So I want you to keep that in mind because it'll come up soon. So here are some examples. When we did initialize the work of building models for nuclear power plants for operator training simulators, there were a lot of things we had to do. Now, you can imagine that a nuclear power plant is an extremely complex thing. there might be 50 or 60 interlocking fluid in atmosphere and room in electrical systems all working together, all connected. And every one of those systems has a whole pile of components, and all those have connections to a whole forest of control panels. So the original discovery phase is a review of the hardware, and it determined what parts we have to think about. Then we did collected data from the control panel readings and any other electronic logging kind of sensory information we could have. And then we did the analysis of what was going on in the system by reading all these system manuals, understanding thermodynamics and electrical power and circuit logic and so on. And then we had to determine all the governing equations. So those were all part of building a conceptual model before we even embarked on doing a design. And that's a lot of different steps. If we're doing planning, we have to think about how we do it from the point of view of a project manager who is concerned with resources and time and the big three, the iron triangle items, business and analysts do things a little bit different. They're worried about requirements in the solution, so they're more down in the weeds. And then we have to close everything out, do lessons learned, and so on. If we're doing design, I already went through a 3-layer design, but there are many other ways you might need to do this. If we're doing implementation, we do develop standalone components and we run individual tests on our desktop. Then we submit them to be integrated and tested at the system level, and then we do deployment and turnover in another set of testing. So let's see how the SDLC looks. We just finished an SDLC exercise. We did all of this stuff. Well, we didn't do it all. We didn't do the last two phases, but we have kind of a rough feel for how this works in general. So there's another way to represent this thing. Oh, by the way, this particular graphic comes from the SDLC page on Wikipedia, at least as it existed a few years ago. So it may still be the same. If we draw all these steps exactly the way we drew the phases, the way I think about them, we see that we have all the phases with similar names with all of 2 additions. This one smuggles in a planning phase, and it breaks apart the implementation phase into development and implementation. And what they mean by implementation here is a combination of deployment, training to handover, and so on. And there's the integration and tested reality. That's a very complex, involved process that happens at all phases, and it might be much more complex and involved and iterative than what is shown here. But essentially, the way I think about things is basically akin to the SDLC. So this is really software is just a subfield of systems engineering, project management, and so on. And there is an accepted way to get things done effectively. So let's do a direct mapping. So I think the SDLC phases, the way they're presented, are a little jumbled. Not much. They're pretty close. But you've got, here's my framework on top, full life cycle, and then the SDLC down on the bottom. The correspondence is very high. The implementation and test is broken up a little bit in a funny way, I think, but there's also some pre-planning, or I think of it as project managers putting a wrapper around the whole process. But if you think of all the things that have to be done, think of the fact that iteration between phases happen. And also, if you think of the fact that nothing ever happens the same way in a form of fixed order, you can see that all the pieces are there. Now let's look at the SDLC framework as shown on the bottom. First, the activities that we engaged in during our 11-week exercise we just finished. I think this is kind of fun. So week one, we did a kickoff and SDLC overview, and I hope you can see the writing in detail on all these slides. I tried to make them readable, but there are some formatting issues. I needed to fit a lot of writing on these also. So we started off with the overview and kickoff. We gave you an idea ahead of time of what you were already doing, so you didn't actively do this work, but you did start to plan a little bit. Then we did requirements, and so that's the beginning of the work in the requirements phase. Now, we had, at least on Team 6, I had us go back and create kind of an understanding of what must be there, because our charter was to automate a system that existed, but we weren't given a lot of details about what the system already did. So we created the conceptual model, then we created the requirements. So in week 3, we've gone through requirements analysis and modeling, so that obviously involved requirements. Then we got to the backlog grooming and prioritization. Again, that's requirements. Then we did design, that's a straight one-to-one. Then we did development and prototyping, so that's obviously development. Then we got QA strategy in week 7 in early testing. So we have to look at the design and figure out how we're going to test it. Then we did UAT and feedback in week 8, that's user acceptance testing. And then we start, that's obviously more testing, and then we start getting into deployment. Then we did deployment and launch prep in week 9. In week 10, it's retrospective and continuous improvement. So that's really what we should have been doing as a practical matter. We were still scrambling to do work in development, design, and implementation right up to the end. You can also argue that after the implementation, there's sort of a ghost planning or closeout phase as a bookend to this planning phase over here in phase 3. So weeks 10 and 11, instead of pointing to the ongoing phases or the end of life phase, should really plan to the point to that closing phase that is implicitly there but not shown. So we basically work through the SDLC. You can't necessarily do items that correspond to every phase, but we came pretty close. So again, knowing what the names of all these things are, having solid, consistent languages for everything really helps you understand what's going on and what work you need to do and who you need to work with no matter where you find yourself. So now I'm going to map every chapter of the BABOK to my simplified framework. So I have been mucking around in the BABOK for about 7 years now, and every time I revisit that material, I learn something new. One of the things that I learned was that the BABOK fundamentally does not talk about how you do implementation in tests. Really doesn't go into it. We did that on the SDLC. I think BAs should be involved in the full life cycle from beginning to end, just monitor things and help try things and have a better understanding of the full process. But as a formal matter, they're really only interested or involved, according to the BABA, in conceptual modeling through design. So somebody has already come up with an idea and gotten an effort started and identified problems and the need for a solution before the BAs ever get involved. So let's look at the actual activities in chapter 3. It's plan business analysis approach. These are all the tasks. Plan stakeholder engagement, plan business analysis governance, plan business analysis information management. That's all in the planning or opening phases. They're not really shown here, but they're really embedded in the intended use area, or a pseudo planning area shown in the SDLC, kind of after the intended use. And then identify business analysis, performance improvements. That's kind of a meta activity we do through all our work. It's not just in planning and monitoring. Well, it is in monitoring, and I'll come back and talk about that in a minute. That is work we do about the way we do our work throughout all phases of our work. So that's an ongoing thing that we do. Looking at chapter 4, that's about elicitation and collaboration. So we elicit to find out what's going on now. We also elicit to find out what the requirements are, what we need. And then we manage stakeholder collaboration through all the three phases that BAs work in this. So there's a couple of comments I want to make here. One is that elicitation is a goofy word for gathering information. So I think of that as eliciting a response. And it's an active thing you do it to get information or some kind of an action in return. And you do that when you're finding out what they already have, what your customer has, what your customer wants. But if I had 3 oranges sitting on a table, so the fact that I saw some oranges sitting on the table as a form of discovery, would that be elicitation? Did I elicit from the universe the fact there were 3 oranges sitting on a table, or some oranges? And if I further did data collection, counted the oranges, and found out there were 3, did I elicit that from the environment? I mean, I'm not saying it's wrong. If you have to do an exam, you should think about it in terms of the way the BABOK gives you this information. I think it's goofy. I think discovery and data collection are the better ways to think about this in service of building a conceptual model. Elicit is generally something you get from people. I also have the insight that in the early phases, you are eliciting needs and direction from the customer, but in the later phases of a cycle, as you are doing design, implementation, and test, particularly if you're doing it for a customer independently, you're eliciting feedback. So you're showing them something and then seeing whether they like it. So the elicitation almost goes the other way. Either way, the elicitation is you prepare for it, you actually do it, you confirm the results, and you communicate the information That all speaks to the iterative nature of elicitation in these activities within every phase. What those items say is we're having a back and forth conversation until we reach agreement. And then we manage stakeholder collaboration through all phases of a project. It's a kind of a meta thing. There's a parallel in project management. I will get to that in a moment. Let's look at Chapter 5, Requirements Lifecycle Management. Well, this one is a slam dunk. They're all about requirements. So what you do is trace requirements, that task 5.1. Then you maintain them, so you'll document them. Then you'll prioritize them, so that's when you figure out what order you're going to address them in. Then you assess changes, and that's a change management situation, or it is reviewing their requirements and continually updating them until they are both verified, which means they're in the proper format and usable, and validate them, which means that they address the actual business need. And then once all that's done, we approve it. So all these are about requirements and about working through to finalize them through that iterative conversational circular process. Could not be more straightforward. Chapter 6 talks about strategy analysis. So in this case, we analyze the current state, if there is one. And that means that we do the conceptual modeling, right? Then task 2 is define the future state. That involves requirements and design as both an abstract form of the future state and a more concrete form of it. Then we assess risk. The way I think about it is we do that through the entire life cycle or the entire engagement. And then we define our change strategy, and that involves design, implementation, and test, all of which again are done iteratively. Chapter 7 is requirements analysis and design definition. So this one is where we go from the requirements to the design. So we verify and validate requirements. I think the BABOK is double dipping. I've always had the feeling that the BABOK is talking about the skills you use in various situations. They are more or less in order, but I think thinking about doing these things in the phases the way my framework in a streamlined way and the SDLC does in a slightly more involved way is a cleaner way to think about it. Nonetheless, we'll specify and model the requirements of obviously, then we'll verify and validate the requirements, and we'll define the requirements architecture. I will come back to this point. That has to do with the requirements and the design. Then we'll define design options. Then we'll analyze the potential value of each and pick the best one. So Chapter 8, as it turns out, is really all about doing that last task in the previous chapter. So in this case, they're all about design. We measure solution performance, analyze performance measures, assess solution limitations, assess enterprise limitations, and recommend actions to increase solution value. So let's go back a few pages. Let's look at this. First of all, we're pointing mostly at planning and intended use. Then we're pointing mostly at conceptual model and requirements. Then we're pointing at requirements. Then mostly we're covering the whole life cycle, and then we're doing requirements and design, and then we're just doing design. So the overall trend of the way the BABOK is suggesting that you do the work, it goes in the same order. Now it covers a smaller part of the process, the entire engagement, but it does go in order. It is a valid way to tell the story. There's a lot of great information in the BABOK. I think this information should be included in future versions of it. So let's talk about how we keep track of all the work we're doing. Requirements traceability is definitely a thing. It's not easy to do, especially when the number of requirements and the complexity of a problem starts to get huge. So imagine the Apollo program as a project. There would be millions of these little dots, and there would be multiple phases and separate experiences and so on. It's just crazy how Byzantine the whole thing can be. However, I am showing a very simple, abstract version of it. So we'll start with a few identified intended uses, and then we'll look at all the items going on in the conceptual model in the as-is state, if there is one. All right, and then we will move forward to requirements based on what we need. So when we're doing a simulation, we have to simulate everything that's in the conceptual model, everything that's in the system. So why do I have these arrows between these things? What this is showing us is that everything we do has to map in both directions to something in the adjacent phase. So all the requirements we have to address what's in the conceptual model, and also everything that's in the intended use with the overall business need. The design, there should be an item that should map back to all the requirements. Now, these things may map one to one, one to many, or many to one in both directions. So this can be as complex as you want. Once you come up with a design, then you have to implement all elements of the design, The test can be as complicated and multi-stage as you want, and then the results of every test can be accepted or not. Down here, may have methodological requirements for each phase. Your organization may have specific standard ways you do things. There may be legal and regulatory ways you have to do things. So that's what these show. And then non-functional requirements may address the intended use, or they may be just injected. And remember what I said about the fact that you iterate forwards and backwards across all these phases. That's when these things up here at the top, these dashed lines go into question marks. So if you learn something in the implementation that requires a new design element, well, you go back to design and add it. Similarly, you can create a new design requirement for a design, a new conceptual model item for a requirement, and you can even create or modify intended uses. So that shows the iterative nature of this whole process. Requirements traceability across all the phases throughout the engagement process is complicated and most groups do not do it very well. I linked to a discussion where I talk about all the ways this happens and can happen and the different orders that can things can happen in. So please check that out if you are so moved. Now let's think about something else. That's the way I think about traceability, is through the engagement. When the BABOK talks about traceability, and when the SDLC talks about architecture, it talks about all the relationship of all the elements to each other. That is the internal design logic in a hierarchy. So I showed that vertically in green here. Um, Up near the top, imagining airplane, you've got one airplane, then you've got a wings, engine, fuselage, tail, some components also, the whatever it's carrying. You've got other mission systems, electronics, communication, landing gear and safety and stuff. So all those can be subsystems and all those can be broken down infinitely almost below that. So that's your logical design hierarchy. That's what the BABOK and SDLC talk about. I showed them they should match up through the in the design phase. So you can think of them marrying up its two views of the same series of items that marry up perfectly. I actually, in this link, describe a way to keep track of both of these using a particular tracking system that nobody has implemented, but they should. All right, let's talk about the differences between the way project managers think about things and the way BAs and other practitioners do. So this grid down here is the way the PMBOK, the Project Management Body of Knowledge, the equivalent or the sister publication of the BABOK, which is the Business Analysis Body of Knowledge, used to teach project management this way. There are 10 areas you think about, and you initiate a project, you plan it, then you execute and monitor and control it, then you close it. So the project management wrapper I talked about was initiation and plan and then close, right? All the BA work goes on, and in reality, BAs don't do implementation and tests, but somebody does. And I think BA should be involved with it. They all happen, all that work is done during execution and monitoring and control. So there were a couple of things I wanted to revisit. If you remember, there was one item in a chapter of the BABOK that talked about monitoring. You're monitoring the ongoing performance, the methodology of doing all the business analysis work. That kind of is akin to what the PM is doing. There was another one too, where the BAs, I can't remember the details offhand, but there was something else on here where the BAs do something similar across all the phases. You know, let's think about all these specific areas also. What do BAs do in common with project managers? So yeah, they worry about integration. They certainly worry about scope. I mean, the BAs worry about scope in terms of what the solution needs, and the PM worries about scope in terms of what will and won't be done and can be done. BAs don't worry about schedule directly, and then don't worry about cost. They might analyze cost of the solution, but they won't have much to or anything to do with the cost of actually doing the work. They might worry about quality. BAs might, hopefully they do, maybe not quite the same way as PMs. PMs again are managing cost, quality, and time. So the big three in the iron triangle. Resource management, BAs won't worry about that, PMs do. Communications management, definitely there's a space in the BABOK for that. It's an important part of how BAs communicate with people. Risk management is something everybody does all through the project. So that's both PMs and BAs. Procurement management is more of a PM thing. And stakeholder management is kind of like communications management. BAs doing something similar. All right, we're almost to the end here. So how do you make sure the analysis is thorough? You want to consider things from all angles. And it's by getting people that do a bunch of different things, think about things a bunch of different ways, and have different skills and experiences that allow them to see things from different angles and then work together. And that's the important part. To really get a full understanding of everything that's needed and how the pictures all fit together. That's a cool book, but it's a super cool cover. I always like including it. And the customer gives the ultimate review, whether that's a specific customer or the mass market customer. It tells you how well you're answering their needs. The final thing to say is, you know, there are no silver bullets or final answers. And this is a tiny sliver of my library I have on these subjects. And if you look on Wikipedia under any management or computer methodology, you'll find a section on criticism. And the criticism always say the same thing. Well, there's no guarantee that if you use all these methods that you'll get the correct answer. Well, that's true because, like I said at the beginning, it's more of an art than a science, and none of this is a cookie cutter way of guaranteeing that you will arrive at success, glory, fame, and fortune. It's just a lot of hard work, understanding the tools you have available, and putting a bunch of heads together, working with free and open communication, mutual empathy and respect, having ongoing conversations, and solving problems the best way you can. Some of the things we're trying to accomplish are complicated systems are getting more complicated. Half of what we're trying to manage in the system has more to do with complexity than it does the actual little bits we're dealing with. So, what that book, Facts and Fallacies of Software Engineering, talks about is how all these great ideas come down the pipe and everyone is touted in turn as this is gonna change the world. It's gonna solve all your problems. And like Pedro and Napoleon Dynamite, it'll make all your dreams come true. Well, that's never been the case. It's never going to be the case. Every new innovation turns out to be extra helpful in one limited area and represent an incremental advance more generally. So that's what you have to be aware of. This has been going on for not 50 years, at this point, over 70. There's nothing new under the sun. I'm glad you are all here, wanting to learn about this stuff, think about this stuff, get better at this stuff, and share all this knowledge with everyone you know. I often say you know, we run these classes to help you pass your certification exams, but I really don't care that much whether you actually pass your exams so much as I care that you become great analysts. And the fact that you are here listening to this shows that you have the curiosity and passion, and you're on your way to doing just that. So thank you for your time. There's a bucket load of extra information at my website. You can find my email on LinkedIn. So feel free to shoot me any questions you like. And that's all I have to say. Thank you very much.